Hello students, welcome you all in this video where we are going to solve section B chemistry of CBSE sample question paper class 10 2025-26. Already I have solved section A biology and I have uploaded the video on my channel. Visit my channel, watch my videos, and if you are getting little bit also help from these all the videos, please consider subscribing my channel. So let's start with section B chemistry. So in this section, question number 17 is a multiple choice question which is going to carry 1 mark. So we will start with the question. Which of the following equation represent redox reaction and what are the values for P and Q in this equation? So here we have two equation 1 and equation 2. We have to find out which equation is redox reaction and then we have to find out the values of P and Q. These are the coefficients used to balance these equations, so that we have to find out. So here we have first equation, Fe2O3 plus aluminium gives aluminium oxide Al2O3 plus iron Fe, and here the heat is liberated. Because of this large amount of heat, whatever iron we are getting, it is in the liquid form. Then equation 2 is C4H10, that is butane, react with oxygen. It is nothing but a combustion reaction, and we are going to get carbon dioxide and water. Here water is in the gaseous form because this is a combustion reaction, so heat will be liberated, and due to large amount of heat, whatever water is going to form, that all liquid water will evaporate to become gas. So these are the two reactions or the equations which is given, and we have four options. Out of this, correct one we have to choose. So option A, only equation 1 is redox reaction and P is 1 and Q is 3. Option B, both equation 1 and 2 are redox and P is 2 and Q is 4. Option C, only equation 2 is redox and P is 2 and Q is 10. Option D, both equation 1 and 2 are redox, P is 2 and Q is 10. So here we have to focus on which reaction is the redox reaction. What is redox reaction? The redox, if you see this word, there are two words which are combined. The first word is red, that is nothing but reduction, and the second word is ox, and that is nothing but oxidation. So here reduction and oxidation both, if simultaneously takes place in the reaction, then that reaction is called as redox reaction. So we have to find out the equation in which the elements, if one substance is undergoing oxidation, then the other one should go reduction simultaneously, and that we can do it by understanding the oxidation states of these all the elements. So what we have to do, we have to find out the oxidation state of Fe, oxygen, aluminium, carbon, hydrogen, and this oxygen, and we have to check is that oxidation state has been changed when it becomes a product, and whatever change has occurred, in that change it has increased or decreased, means it has lost electron or it has gained electron, that we have to find out. If it loses electron, then it is undergoing oxidation. If it gains electron, then it undergoes reduction. And based on that knowledge, we can easily find out which equation is oxidation, redox, and which equation is a correctly balanced one. So let me start with the finding oxidation state of all the elements. So here I will take first equation number 1, and the equation number 1 is Fe2O3 plus aluminium. So write down the coefficient, that is 2 aluminium. Here I am not writing the states because I am going to write the oxidation state, so we will get confused a little bit, so I am not writing the states. Gives Al2O3 plus PFE, and heat is liberated. So here I will write H for heat. Now we have to find out the oxidation state. So first I will take, let me write it little bit of down so that you should not get confused. Fe2O3. So in this Fe2O3, I will find out the oxidation of iron, and for that, as we have here 2 iron, so I will take 2. Oxidation state now I don't know, so I will take X plus, now here 3 oxygen, and oxidation state of oxygen is, as we know, it is -2, and overall oxidation state here there is no number, +2, -2, nothing is there, so we should consider it as 0. So that's why I'll write it here 0. So is equals to 0. Overall oxidation state is 0. Now 2 into x is 2x, plus or minus minus 3 2s are 6. So 2x, so here write down equal to 0. 2x is equals to shift this minus 6 on that side, so it will be 6, and x is equals to 6 divided by 2, and here I am going to get answer x is equals to 2 1s are 2, 2 3s are 6, so here plus 3. So oxidation state of Fe in Fe2O3 it is plus 3, so I'll write it here plus 3. We got, and for oxygen I told it was minus 2, so minus 2. Aluminium, if you focus here, this is a atom, so element don't have any oxidation state, so it is a pure, it is in a pure state, so zero oxidation state. Now reactant side is completed. Now come to the product side. Product side, here we have Fe, again it is a pure, so here oxidation state is 0, and for Al2O3 we have to find out the oxidation state of aluminium. So for that I will write it here Al2O3, and same process we have to use. I don't know the oxidation state of aluminium, but I know how many aluminium, 2, so therefore 2. Because I don't know the oxidation state, I'll take x plus 3, oxygen is minus 2, is equals to overall it is 0. So now, so solid 2x plus or minus minus 6 is equals to 0. I hope you're understanding. 2x minus 6, that side we will shift. X is equals to, we are going to get same answer, that is x is equals to plus 3. So this is the oxidation state of aluminium. So I'll write it here plus 3, and here I'll write down for oxygen it is minus 2, sorry, so I'll write it here minus 2. Now if you see this reaction, if you focus the reaction, see the iron in the reactant side, this is the reactant side, so in reactant side iron was plus 3, and once it becomes the product it became 0. Here it was plus 3 and now it became 0. So here the oxidation state has got decreased. So what is the meaning of this? Once the oxidation state has got decreased, means iron has reduced. So here I will write Fe reduced. So we can write like this. Now focus on oxygen. Oxygen here also minus 2, here also minus 2. So there will be no change. Now see aluminium. Aluminium, this side it was 0, but on other side if you see it is plus 3. So what is the meaning of this? Earlier it was 0. Now after the reaction in product it is plus 3, means oxidation state has increased. So here aluminium has got oxidized. So here I'll write oxidized. So by this, what we can say, in this reaction, iron has reduced, aluminium has oxidized. So this is a redox reaction. So it is proved that this is redox reaction. So equation 1 is redox reaction. Now we will see equation 2 and then we will go for balancing. So I'll write here equation 2. So equation 2 is, that is 2C4H10, then 13O2 gives, it undergoes combustion, it gives 8CO2 plus Q, we have to find out H2O. So this is the reaction. Now again in this we will find out the oxidation states of all. So here if you see oxygen, it is in the pure state, so 0. Here we have 0 oxidation state. We have to find out first for carbon. For carbon, I'll take here C4H10. Now we have to find out for carbon. Therefore, I will take X for carbon. So we have 4 carbon. So I took 4. X is the oxidation state of carbon, which we don't know. So I'll took X. Then plus, how many hydrogen? 10. Oxygen state of hydrogen, as we all know, plus 1. And overall it is 0. So I wrote 0. So 4X plus 10 is equals to 0. Then it will be 4x, shift 10 on that side, so it will be minus 10. X keep as it is, minus 10 divided by 4. So here what we will get, if you divide this, x value we will get 2.5. 2.5. 4 2s are 8, again 2 will remain, then 4 5s are 20. So here we got 2.5, so I will write here 2.5 for carbon, and hydrogen it is plus 1. Now, if you go on the other side, here we have CO2. So for CO2, we will find it out. CO2, I will write it here, CO2. So as I told, I don't know the carbon oxidation state. So carbon here only 1. So X plus 2, and oxygen state, as we all know, it is minus 2, is equals to 0. So x plus or minus, minus 4 is equals to 0. Shift on that side, so we will get, so here the oxygen state of carbon became 4. So this I will write it here 4. Oxygen we know here minus 2. Hydrogen here it is plus 1. Oxygen here it is minus 2. Now if you focus on this reaction, in this reaction here I forgot to write the sign, sorry for this mistake. So here it is minus 2.5 and here also we have to write minus 2.5. Now if you focus the equation, carbon on this side, if you see, carbon was minus 2.5 and after the reaction it became plus 4. You can see this, it became plus 4. So the oxidation state of this has got increased. I hope you are understanding. The oxidation state of this has got increased. It from minus 2.5 it became plus 4. So what is the meaning of this? The meaning is carbon has got oxidized. So here for this reaction I will write it here somewhere. It has got oxidized. Carbon has got oxidized. And see oxygen, here it was 0. It was 0 and on the other side if you see, oxygen has become minus 2. So oxidation state has decreased. So oxygen has reduced. So carbon has oxidized and oxygen has reduced. So in this reaction also, one substance has undergone oxidation, other substance has undergone reduction. Therefore, this reaction is also a redox reaction. So in this equation I can write, so this is also a redox reaction. So now if you see, both the reactions are redox. If you focus on the option, only first option is only equation 1 is redox. So this is a wrong option. Both equation 1 and 2 are redox. So this is correct. Only equation 2 is redox. So this is also wrong. Both equation 1 and 2 are redox. So now we have two choice, B or D. From B or D, any one option is correct. That we have to decide with the help of P and Q value. Now to find out P and Q, if you see in the first reaction, this side Fe, how many we have? We have 2. Oxygen, how many we have? 3. Other side, oxygens are correctly balanced, 3 and 3. But iron, here we have 2, but here we have only 1. If I write here 2 in place of P, then this reaction will be balanced. So P should be how much? 2. I hope you are understanding. So in the first equation, P should be 2. Now, this is very easy to balance. In the second one, if you see here, carbon 4 2s are 8. Hydrogen, here how many we have? Hydrogen, if you see, H10 and this is 2. So here 20 hydrogen we have. Oxygen 13 2s are 26 we have. This side if you see, carbon how many we have? CO2 we have here 8. So carbon is balanced, 8 correctly balanced. 8 2s are 16 oxygen and here we have 26 total. So 16 oxygen means how many are still remaining? 10 oxygens are remaining. Hydrogen we have 20, here we have 2 hydrogen. So we want 20. So if you multiply with 10 in place of Q, if I take 10, then hydrogens becomes 20, oxygens becomes 10 and oxygen correctly balanced 26. And like this if you see, then the equation 2 Q should be 10. And according to this, if you see in the options, option B, P is 2, Q is 4. So this is also a wrong option. And option D, P is 2 and Q is 10. So this is the correct option. That's why option D is correct. So here in answer I have wrote D, both equation 1 and 2 are redox reaction and P should be 2 and Q should be 10. So this is the correct answer and correct explanation for question number 17. So now question number 18, again a multiple choice question which is going to carry 1 mark. 4 statements about the reaction of oxides with a dilute hydrochloric acid and aqueous sodium hydroxide are listed. So here we have 4 statements about the reaction of oxides with dilute hydrochloric acid and with aqueous sodium hydroxide. So hydrochloric acid is acid, aqueous sodium hydroxide is base. So we are going to react oxides with acid and base and here we have 4 statements. So statement 1, Aluminium oxide react with both dilute hydrochloric acid and aqueous sodium hydroxide. Second statement, calcium oxide reacts with dilute hydrochloric acid and aqueous sodium hydroxide. Third statement, zinc oxide reacts with both dilute hydrochloric acid and aqueous sodium hydroxide. And the fourth statement is sulfur dioxide does not react with either dilute hydrochloric acid or aqueous sodium hydroxide. So these are the four statements, and now in the options they have given option 1 and option 2. So here we have to see which statements are correct. If statement 1 and statement 2 is correct, then correct mark option A. If statement 1 and statement 3 is correct, then mark B, and so on. So now we have to start with the answer. So we will start with the answer. Now first statement, if you see aluminium oxide. What is aluminium oxide? Aluminium oxide is Al2O3. It is called aluminium oxide. Then aluminium oxide reacts with both dilute hydrochloric acid and an aqueous sodium hydroxide, they are saying. So before going to the answer, first we will see the types of oxides. So types of oxides. So we have three types of oxides. First one, acidic. First one, acidic oxides. And who will give acidic oxides? All non-metals. Non-metals will give acidic oxides. Then second, we have basic oxides. And basic oxides we are going to get from metals. We are going to get from metals. And then we have one more type which are called as amphoteric oxides. So amphoteric oxides means what? The oxides which show both the properties. They will act as acid, sometimes they will act as base also. So acidic oxide means the oxides which behave as acid, acidic property they will show. Basic oxides will show basic property. Amphoteric means which shows both the properties, acidic as well as basic. So here this aluminium oxide, it is showing both the character. It is amphoteric, and therefore I'll write it here. It is an amphoteric oxide. Therefore, it has the property to react with both acid as well as base. So if you see here, hydrochloric acid, it is a acid, and aqueous sodium hydroxide, it is base. And the statement says aluminium oxide reacts with both, and it is correct because it is amphoteric. So first option is statement is correct. In the second statement, if you see calcium oxide, what is the formula of calcium oxide? CaO, calcium oxide. This will react with dilute hydrochloric acid and aqueous sodium hydroxide, they are saying. Means they are saying this calcium oxide will react with both acid as well as base. But calcium is a metal, and metal will give basic oxide. So this is basic oxide. I hope you are understanding. If it is a basic oxide, it has basic properties. And if it has a basic property, base will react with only acids. It cannot react with bases. Base cannot react with base. And therefore, second statement is a wrong statement. Then third statement, if you see zinc oxide, the formula is ZNO, zinc oxide. This is again a amphoteric oxide. So I'll write it here. This is again a amphoteric oxide. And according to this, it should react with both. So zinc oxide reacts with both dilute hydrochloric acid as well as aqueous sodium hydroxide. So this is also correct statement. If you see statement 4, sulfur dioxide, di means 2. So does not react with either dilute hydrochloric acid or aqueous. Means they are saying sulfur dioxide will not react with both acid as well as both base. But in this sulfur dioxide, sulfur is non-metal. Non-metal will give acidic oxide. So here I'll write SO2 is acidic oxide. I hope you're understanding. Acidic oxide. To know these all, you should know the basics first, which is acid, which is base, and which is amphoteric. So if this is an acidic oxide, it should react with the base. It should not react with acid. So this is acid. So it should not react with acid. And they have told sulfur dioxide will not react with acid. But they are saying it will not react with base also. But as we all know, because it is acidic, it should react with base. It should react with the sodium hydroxide. So this statement is wrong. And if according to these all, if you see the statement 1, it is correct. Statement 3 is correct. So search in the option. Here if you see option B says 1 and 3 is correct, and therefore I wrote answer B, 1 and 3. So this is the answer for question number 18. Now question number 19. An iron nail is added to each of the two test tubes P and Q containing aqueous copper sulfate solution and aqueous silver nitrate respectively. Which of the following observation is correct? So here in the question they have given iron nail, that is Fe. The nail is made up of Fe, iron, is added to each of the test tube 2. So we have two test tubes P and Q containing copper sulfate, aqueous solution of copper sulfate. So we are going to take two test tubes in which it is containing aqueous copper sulfate solution CuSO4, and in one test tube there is the aqueous silver nitrate solution, that is AgNO3. So respectively means P test tube containing aqueous copper sulfate solution and Q test tube containing silver nitrate solution. Then which of the following observation is correct? So we have to see the test tube, we have to observe the test tube, and then we have to tell which observation is correct. Now see option A. In test tube P, iron nail is coated with a blue coating. After some time, iron nail will get coated with the blue coating, and test tube Q there is no reaction. Then option B is iron nail is coated with brown coating in test tube P and silver coating in test tube Q. Then option C is there is no reaction in either test tube P or Q. Means in P and Q both the test tube there will be no reaction. And option D is there is no reaction in test tube P, but a silver coating on iron nail is seen in test tube Q. So these are the four observations they have given. We have to write the correct observation from this. So this is the example of actually displacement reaction. So here in displacement reaction, if you see, the more active metal or the element or species will replace the less active species. So here same concept we are going to apply, and for that we should know which is more active and which is less active species, and for that we should know the electrochemical series in which the elements will be arranged in the decreasing order of their reactivity. So let me write the electrochemical series here. So I will write it here, electrochemical series, which will help us to solve this question. So it is already given in the NCERT book. So I'll write it here, electrochemical series. So in this series, more active metal, that is potassium, comes first. After this we will write sodium, then we can write calcium, we will write Mg, then we will write aluminium, then comes zinc, after zinc iron, then there is a lead, that is Pb symbol lead, then comes copper, after this we have Ag silver, and then we have gold. If you see, these all the elements are more active or you can say reactive, and as we go down the reactivity decreases. So here I'll write less active. So I hope you are understanding. As we go down, the activity or the reactivity decreases. So here I'll write reactivity decreases. So this series is called electrochemical series. By using this series we can answer this question. So here I will write iron, and this we are going to add in two test tubes. So one test tube, that is, I will write here test tube and denoted by P, and this is containing copper sulfate, so CuSO4, and another test tube which is containing silver nitrate. The symbol denoted by this is Q, and it is containing silver nitrate, means the formula is what? Silver nitrate, it is AgNO3. So here this ion is going to react with copper sulfate in the first test tube, and it is going to react with silver nitrate in the second test tube. So we will write the reaction and we will see either it is going to replace or no. So Fe plus CuSO4. Now see what happens. Here we have to compare this iron with copper. because these are the metals. So if you compare this iron and copper in the series, iron is here and copper is below. So which is more active? Iron is more active and copper is less active. So when these both comes in contact with each other, because iron is more active, I'll write it here. This is more active, copper less active. So now what happens when this both comes in contact, when iron is added to copper sulfate, iron will go and replace this copper. So what we'll get? We will get copper plus iron sulfate, FeSO4. So copper will come outside and this it will be replaced by Fe. So we will get FeSO4, and this is of which color? It is of brown color. So brown color. So here the iron nail is going to coat with brown color. Now we will see the second reaction. So I will take iron and this is going to react with silver nitrate. So I will take AgNO3. Now we have to again focus on the electrochemical series. So again iron is here itself and still silver is down. It is down than copper also. So copper and silver both are less reactive. If you see silver, it is less reactive than copper also. So we will write it here. Iron more active and this is less active. Now what happens again? Because iron is more active, it will go and replace the silver, and therefore we are going to get silver plus again FeNO3, and here it is twice because we have to balance the oxidation state. Here we have to take twice, and because this we will take here 2, that's why the whole reaction, this also we have to balance, so we have to take it 2 here also, and because of that the 2 should be here also. This is called balance reaction. So this we will get silver separate. You can see here, this we are getting silver separate. So whatever nail is present in this Q test tube, here the nail will get coated with silver coating. So in P test tube, it is getting coated with brown color, and in Q test tube, it is going to coat with silver coating. And now we have to see the options. If you see the option in the first test tube, P iron nail is coated with blue coating, and in test tube Q there is no reaction, it seems. So it is wrong. Then B iron nail is coated with brown coating and silver coating in Q. So this option is the correct one. Now no need to check the C and D option. Therefore, the correct option is option D. So write down answer B, that is iron nail is coated with brown coating in test tube P and silver coating in test tube D. I hope you understood this answer. Now we'll move with next question. Now question number 20. Methyl orange is added to dilute hydrochloric acid and to aqueous sodium hydroxide. What is the color of the methyl orange in each solution? So here we have to write the answer for this question. It is not a multiple choice question. So directly we have to write the answer for this. So if you see this, this is a methyl orange. It is nothing but a acid base indicator. So methyl orange, it is a acid base indicator. There are many type of indicators. Acid base indicator, then we have metal ion indicator, then we have redox indicator, etc. So methyl orange is an acid base indicator, means it is used to check the solution is acid or the solution is base by observing the change in the color. So here this methyl orange we are going to add to dilute hydrochloric acid as well as in aqueous sodium hydroxide, and we have to tell what is the change in the color. So whenever methyl orange indicator, it is originally little bit of orange in color, reddish orange in color, and when it is added in a dilute hydrochloric acid, which is an acidic solution, it becomes orange red in color. So remember, already the methyl orange original color is little bit of reddish, but once it is added in acidic solution, it becomes orange red in color. So little bit color change will occur when it is added in acid. But when it is added in base, sodium hydroxide is nothing but a basic solution, or it is also called as alkaline solution. When it is added in base, alkaline solution, it changes its color to yellow. Whole solution will get yellow color. So if your solution is getting yellow by adding methyl orange indicator, then the solution is base. If your solution is giving orange red color, little bit change in the color when it is added, when this methyl orange is added, then the solution is base. Sorry, the solution is acid. I'll repeat once again. Methyl orange indicator becomes orange red when it is added in acids. Methyl orange indicator becomes yellow when it is added in base. So this is the answer for question 20. Now we will move with question number 21. Question number 21 is, which of the following substances when dissolved in equal volume of water will have the highest pH value? So here they have given some of the chemicals like sulfuric acid, acetic acid, magnesium hydroxide and sodium hydroxide. So if you see this, A and B both are acids and C and D both are bases. Sulfuric acid, a strong acid, acetic acid, a weak acid, magnesium hydroxide, a weak base, and sodium hydroxide, a strong base. Out of these four, which one, when dissolved in equal volume of water, will have the highest pH value? That we have to tell. So the answer is, first you should remember, the substance that will give highest pH will be always a strongest base. We know the pH scale. What is pH scale? So here I will write pH scale. These everything I have explained in acid, base and salt chapter. If you have not watched my video, go through my channel and watch the full chapter, that is acid, base and salts. There I have explained this completely. So in pH scale, if you see, it starts from 0 till 14 and somewhere middle there will be 7. So 0 to 7 till 7 it is acidic. This is acidic. And here it is neutral. Exactly 7 pH means it is neutral, and from 7 to 14 this is basic. So I hope you are understanding. So here 0 to 7 till 7, 6.9 it is acidic, 7.1 to 14 it is basic, and 7 is neutral. In this 0 to 7 which is acidic, 0 means it is highly acidic. This you should remember, highly acidic. And 6.9 means this is less acidic. This everything I have explained in my video which I have already uploaded. Go through my channel, you will understand everything. Then from 7 to 14, here 7, this is nothing but less basic. Less basic means from 7 it is going to start to convert into basic, therefore it is less basic. And this 14 means it is highly basic. So according to this pH scale, if you see the statement, the base substance that will give highest pH will be strongest base, correct? This is the highest pH. You can see 14 is the highest. So if your solution is giving 14, 13 or 12, then it will be a strongest base, that is highly basic. Now if you see again answer, the substance that will give the highest pH is the strongest base. Remember this statement and then we will solve. So what is sulfuric acid? Sulfuric acid, it is nothing but H2SO4. It is a strong acid. Whenever H2SO4 is added into the water, all H2SO4, whole H2SO4, all the H2SO4 molecules will split to give H plus and SO4 minus 2. Now to balance here I have to take 2H plus. Means whatever amount of H2SO4 we will take, all H2SO4 will dissolve. It splits to give more number of H plus and SO4 minus 2. Because of more number of H plus, the pH value becomes less. pH value will be decreased. It will become 0, 1 or 2. But in the question they have told highest pH. And that's why this cannot be the correct one. I hope you are understanding. Acids will be always have pH from 0 to 7. And whichever is strong acid will have pH between nearby 0, 1, 2. And in the question they have told highest. So this cannot be the correct one. If you see acetic acid, the formula is CH3COOH. This, when it is added in water, it will also split to give CH3COO minus and H plus. But because it is a weak acid, all CH3COOH molecules will not split to give H plus, means you will have less H plus, and because of less H plus, it will be a weak acid. So acetic acid is a weak acid, and because weak acid, it will have pH somewhere 4, 5, 6. So this also will not be the correct one, because in question they have told highest pH. Highest means somewhere near to 12, 13, 14. Now if you go for magnesium hydroxide, it is a base, MgOH twice. It is a base because once it splits, when it is added in water, it becomes Mg plus 2 plus 2OH minus. It gives OH minus. But because it is a weak base, it will not give more OH minus. It gives less OH minus. Less OH minus means what? It is less basic. So its pH will be somewhere near 8, 9, 10 like this. So in question, as I told, it is highest pH. Now we will focus on the next one. Sodium hydroxide, that is NaOH. And this is a strong base because when it is added in water, all NaOH molecule will split to give Na plus and OH minus. All NaOH molecule. Therefore, whatever OH minus ions we will have, those will be more in number. And because OH minus are more, they will be highly basic. And because highly basic means the pH value will be highest, somewhere 13 or 14. According to the question, this will be the exact match for this question. As I'll be telling, MgOH twice, magnesium hydroxide, this is also base. Sodium hydroxide also base. But magnesium hydroxide is weak base. Its pH will be somewhere between 7, 8, 9 and 10. But if you see sodium hydroxide, its pH will be somewhere 13 and 14. So this will match to our question, and therefore option D is the correct. Sodium hydroxide strong base fully dissociates in water. So D, sodium hydroxide. This is the explanation of this question number 21. For detailed explanation, you go through my channel and watch full video of acid, base and salts chapter. You will understand everything basic of this chapter. So after this, we are going to move with next question. Now the next, that is question number 22. When excess of carbon dioxide is passed through lime water, the milkiness disappears because. So this is again a 1 mark question. So here we have 4 options. So when carbon dioxide CO2 is passed through lime water is nothing but calcium hydroxide, CaOH twice. So when this CO2 is added to lime water, the milkiness will disappear, and that is due to what? What is the reason that we have to tell? So option A, water soluble calcium carbonate converts to water soluble calcium bicarbonate. Second one is insoluble calcium carbonate converts to water soluble calcium bicarbonate. C. Water soluble calcium carbonate converts to insoluble calcium bicarbonate. And D is insoluble calcium carbonate converts to insoluble calcium bicarbonate. So these are the 4 options which are given. Now answer we will see. When excess of CO2 is passed through lime water, so what happens that we have to tell. This we have to see step by step. So first we will see, when we will pass carbon dioxide in lime water, what will happen? And then when excess of carbon dioxide is passed through lime water, then what will happen? So first one. First, milkiness appears due to formation of insoluble calcium carbonate. So whenever CO2 is passed through lime water, calcium carbonate is formed, and this is insoluble, which will not dissolve. It will remain as it is, and due to this, we can see the formation of milkiness into the lime water. So that can be shown by the following reaction. So what we have to do, we have to take calcium dioxide, or we can say carbon dioxide, and this we are going to pass in a lime water. Lime water means calcium hydroxide, that is CaOH twice. And when this CO2 effervescence are passed in this calcium hydroxide, this will form calcium carbonate. Calcium carbonate, and this will be insoluble. So this downside arrow shows it is insoluble, and with this it will form water. So that is H2O. So whatever this calcium carbonate will form, this will give milkiness to the lime water. So this is the first reaction takes place when CO2 is passed to lime water. So this CO2 is little bit, it is not excess. Little CO2 when it is passed to lime water, we will get milkiness. Now suppose in the same solution of this milkiness lime water, if we supply excess of CO2, then what will happen? That now we have to see it here. With excess of CO2, this insoluble CaCO3, which is here, this insoluble CaCO3 reacts further to form water soluble calcium bicarbonate. So whatever CaCO3 it has formed which is insoluble, in this if we supply excess of CO2, it will further react to give calcium bicarbonate, and it is water soluble. So the milkiness disappears. So I hope you are understanding. So this we can show by the following reaction. So now what we have in the test tube, we have calcium carbonate which is insoluble, or I can write here milkiness, which is giving milkiness due to insoluble. So that also I'll write it here, insoluble. If we add excess of CO2 in presence of the water which has formed in the above reaction, you can see here, this will give calcium bicarbonate. So that is CaHCO3 twice. And this calcium bicarbonate is soluble. This is soluble. So once this whole gets soluble, dissolves, the water will become clear. So earlier it was little bit of milkiness, whitish, but after passing excess of CO2, it became soluble or clear. Now we can check our options. So in the option, water soluble calcium carbonate converts. Water soluble calcium carbonate, it is not soluble. So this is wrong. Option B, insoluble calcium carbonate converts to water soluble calcium bicarbonate. This is the correct answer. Now if I want to see the C and D also, water soluble calcium carbonate, it is not water soluble. Insoluble calcium carbonate converts into insoluble. So your calcium bicarbonate is not insoluble. So therefore this is also wrong. So therefore the correct answer is option B. Here I will write the answer. So I'll write answer, that is option B. And in front of that we should write insoluble calcium carbonate, that is CaCO3, converts to water soluble. So I'll write it here, water soluble calcium bicarbonate, CaHCO3 twice. So this is our answer for question number 22. Now we'll move to the next question. Now question number 23, in the reaction of aqueous solution of barium chloride. So barium chloride means BaCl2. It is aqueous with aqueous solution of sodium sulfate. Sodium sulfate is nothing but Na2SO4. So this both the aqueous solution, if we mix each other, if we react each other, then the aqueous solution formed will be, then in the product, which will be the aqueous solution? Aqueous solution means what? The substance which is completely dissolved in the water, that is called as aqueous solution. So here the options are A BaCl2, B BaSO4, C Na2SO4, and D is NaCl. Now we will see the answer of this. If you see the option, our reactant is, one is barium chloride and the another one is sodium sulfate. What is barium chloride? The formula is BaCl2, and the another one is sodium sulfate, that is Na2SO4. Then if these are the reactant, then product cannot be BaCl2, so therefore A option will be wrong. Again product cannot be Na2SO4, this is also wrong. So now the remaining option is option B and option D. Out of these two, Whichever is correct, that we have to answer. So see the answer. When aqueous barium chloride reacts with aqueous sodium sulfate, double displacement reaction occurs. Double displacement reaction means what? Both, all the ions will get exchanged. Now see here, BaCl2 reacts with Na2SO4. So this is AQ. AQ is explaining the state of the solution. State is aqueous. So here AQ. So BaCl2 plus Na2SO4, when it combines, now see, this Ba is positive, Cl is negative, Na is positive, SO4 is negative. So this positive combines with this negative, and this negative combines with this positive. So what we are going to get? We are going to get BaSO4 and NaCl. But in these two products, BaSO4 is in the solid form. So this will give precipitate. I'll write it here, PPT. This will get precipitate, white color precipitate. And what about NaCl? NaCl is a sodium chloride salt which will be dissolved in the water. So this will dissolve in the water means what? It will form aqueous solution. And the question asks, the aqueous solution formed will be, so aqueous solution is our NaCl. Therefore, our correct answer is option D. So here BaSO4 is insoluble, forms white precipitate, and NaCl remains in the aqueous solution. So therefore, correct answer is option D. So this is the answer for question number 23. After this, we will see the next question. Now the next question, we are going to see question number 24, and it is having assertion and reason. It is again carrying 1 mark. So first we will read the question. The following question consists of two statements, assertion and reason. Answer these questions by selecting the appropriate option given below. So we have here 4 options. A says both assertion and reason are true, and reason is the correct explanation of assertion. B says both assertion and reason are true, and reason is not the correct explanation of assertion. And C says A is true but R is false. Means reason is true but assertion is true but reason is false. D says assertion is false but reason is true. So by seeing this assertion and reason and their relation, we have to choose the correct option from this. So we will see the question number 24. Assertion is C4H8, C4H6 and C4H10 are members of the same homologous series. They are saying these all 3 members are of same homologous series, and the reason is C4H8, C4H6, C3H4, C3H6, C2H4, C2H2 are unsaturated hydrocarbons. So here now we have to first check these both are true or no, and then we have to see these are both are related or no. Means the reason is correct explanation of assertion or no. So what is homologous series? Homologous series means the series in which all the compounds will have the difference of CH2 group in those. The successive member of these all homologous series should have the difference of CH2. That is the main explanation of homologous series. Now if I see our compounds, one is C4H8, second one is C4H6, the next is C4H10. If you focus these all the 3 compounds, see the difference between these two. There should be the difference of CH2 group. 1 carbon should be extra and 2 hydrogen should be extra. If you focus, there is a difference of 2 hydrogen, but carbon is same. You can see here, carbon is C4. And even in these two, if you see, again there is same carbon, that is C4. So here only the main reason of being homologous, compound of homologous series will be cancelled. And therefore, assertion is completely wrong. If I want to tell you in detail, C4H8, it is nothing but what? You can see here, I will take 4 and then I have to adjust 8 hydrogen. So 1 here, 1 here, 1 here, 1 here. I will adjust 1 here, 1 here, 1 here, 1, 2, 3, 4, 5, 6, 7 and this is 8. So all 8 hydrogen had got finished. Then this carbon will be having lack of hydrogen. Therefore, I will put here double bond. Then here 1, 2, 3, 4, 5, 6, 7 and 8. So again this should have, so here I cannot take the bond because already it has a bond. So I'll remove this bond. I will put a double bond now and then I'll put a single bond here. So now it is correct. So it is nothing but what? It is having double bond, means it is alkene. It is alkene. And last one, if you see C4H10, it is alkane because it is H10. And if you see this one, it is alkyne. So these all are the members of different homologous series. This can form alkane is the member of alkane homologous series. Alkane is nothing but what? This is butane. So here I will write. So this is butane and this is butene and this is butane. I hope you know how to label, name these all. So butane is the homologous member, or it is a member of alkane homologous series here. Then butylene, it is a member of alkyne homologous series. Butene, it is a member of alkene homologous series. These cannot be the members of same homologous series. Therefore, assertion is false. So this is false. We understood assertion is false. Now we will come to reason. Reason, they have told C4H8, these all the members are unsaturated hydrocarbons. Unsaturated means what? The hydrocarbons, either they should have double bond between the carbon atoms, two carbon atoms, or they should have triple bond between the two carbon atoms. Either double or the triple bond. Those hydrocarbons are called unsaturated. If they have single bond, then it is called saturated. Now if you see, just now I have drawn here one C4H8. So this is C4H8. It has a double bond, so it is unsaturated. It is correct. Now next I will draw for C4H6. So I will take 4 carbons and 6 hydrogens means 2. Again I have to remove. So what I should do here? So C3, 1, 2, 1, 2, 3, 4, 5, 6. Done. So here I will put double bond. Here, sorry, I cannot put double bond here. So I will remove. Here I will put double and then I will put triple. Now let me see carbon valence is balanced or no. This carbon has 4 bond, this carbon has 4 bond, this carbon has 4 bond, this is also having 4 bond. So what is this? This is having a triple bond. So this is also unsaturated, this is also unsaturated. Now come to this C3H4. So let me draw here C3H4. So C3 I will take and H I should take only 4. So 1, 2, I will write it here 3 and then I'll write it here 1, 4 over. Now see, this carbon should have 1 bond here. This carbon I will write 3 bonds. So valence check, balance, balance, balance. So this is also unsaturated. C3H6 means what? C3H6 means I have to increase another 2 hydrogens. So I should not take triple bond, I should take double bond. So I took here double bonds here. Then like this H, H, H. I hope you're understanding. Each carbon should have 4 bonds. So that carbon valence will be balanced. 1, 2, 3, 4, 5, 6. So this is also alkene, so unsaturated. Now see next one, C2H4. C2H4. Very easy. C2H4. 1, 2, 3, 4. So each carbon require 2 bonds. So I'll write it here 2 bonds. So this is also unsaturated. And the last one, C2H2, it is ethene. So it's not ethene, it is ethine. So I will write the structure of this. So C and C, only 2 hydrogens. So like this. So how many here bond? There should be 3 bonds. So it is alkyne, ethine. So this is also unsaturated. So reason is true. Assertion is false, but reason is true. But there is no relation between the assertion and the reason. Means reason is not the correct explanation of this assertion. So here I can write like this. So assertion is false, but reason is true. If you see all the options, this will be the correct option. So answer is option D. Assertion is false and reason is true. So this is the answer for this question number 24. Now I will move to the next one. So till here we have completed all 1 mark question. After this we will move with the 2 mark question. So I hope you are understanding all the answers of all the questions. If you have any doubts or anything related to all the questions, you can comment those all the doubts in my videos.